Australian Mathematics Curriculum, Trigonometry, Finding an Unknown Side. You'll remember that we've dealt with the trigonometric ratios, the trig ratios. Sine of the angle is opposite over hypotenuse, cos of the angle is adjacent over hypotenuse, and tan of the angle is opposite over adjacent. We most often use these to find either an unknown side or an unknown angle in a right-angled triangle. Today we're going to use it to find an unknown side. If you look at this question, I have a right-angled triangle. 31 degrees is marked, so that becomes the angle we care about. And I have two other sides. I need to find the side marked x, and the hypotenuse is 10 meters. Now I'm going to skip ahead because we'll want to write down the steps that we need to use. Anytime we do trigonometry and we have a triangle, our first step must always be to label the sides. We'll go back to our question. The sides, here we have x, it's opposite the angle that we care about. It is, of course, the opposite side. Opposite the hypotenuse is the side with 10 meters on it. Sorry, opposite the right angle is the hypotenuse. We label that. Now our other side is the adjacent. There's nothing on that side. There's no letter, there's no value. So while you can label that side, the fact that we've only got something on the hypotenuse and the opposite is what helps us to do the next step. Because our next step is to choose the ratio that we're going to use. So our possible ratios are sine, cos, and tan. We choose the one that has the opposite over the hypotenuse, because those are the two sides we have. We're going to choose the sine ratio. So our first step then, our second step really, is to write the sine ratio. Sine of the angle equal opposite over hypotenuse. Going back to our steps, every time we have a trigonometry problem with a triangle, we will label the sides and we'll choose the ratio. We'll then, of course, because we've got a formula then, substitute our values. Going back to our triangle, I've got values for three things in this. Sine of the angle, well, the angle is 31 degrees. Sine of 31 degrees equals, the opposite is x, I'll substitute x, and the hypotenuse is 10. So sine of 31 degrees equals x over 10. And my next step in all of these is just going to be to solve the equation that we've got from substituting in the values. If you look at that, sine of 31 degrees equals equals x over 10. I want x on its own. I can get x on its own. I've got divided by 10. I'm going to need to multiply by 10 on both sides. 10 times sine of 31 degrees equals x. Now I've got a value for x, 10 times sine 31. Type that into my calculator, making sure it's in degrees mode, and I will discover that x is 5 0.15 meters. Quick check that that is less than the hypotenuse of 10. Yes, it is. And we've done our problem. So the steps you really need to follow are these. Label the sides of the triangle, and that lets you choose the ratio you'll use. Substitute in the values, and then just solve the equation. Now very quickly, just in case we want to know why this works, I'm going to solve this again, or another question, but we'll just approach it a slightly different way. Going back to here, this is the appropriate working. This is the working out we show, but there's a way of doing this that has a little extra step that just shows us why this works. So we have this question. Remembering our steps, first thing I'm going to do is label the sides. Nothing on the hypotenuse, so I don't normally even label the hypotenuse, just in case I was going to get confused. Opposite the angle is x, and next to the angle is the adjacent, 3 meters. Opposite and adjacent means I have to choose the ratio that has opposite and adjacent, and that's tan. So I write the ratio. Tan of the angle is opposite over adjacent. And again, I substitute in the values. Tan of 24 degrees equals, the opposite is x, the adjacent is 3. Now here, normally when we're solving this, I'd multiply both sides by 3, and I'd get 3 times tan of 24 degrees is x, and I'd solve that, and that would be fine. But just looking at tan 24 degrees for the moment, we'll remember that the value, the ratio of tan of 24 degrees is stored in our calculator. If we pause for a moment and just type in tan 24 equals, that will find the value of the ratio that I'll always have in a right-angled triangle with an angle of 24 degrees when I do opposite divided by adjacent. So typing in tan of 24 means I get 0.44523. That's a 5. That's tan of 24 degrees. That's the ratio of tan for any triangle right-angled with 24 degrees. And that still equals x over 3. So I can still solve for x by multiplying both sides by 3. 3 times 0.44523 equals x. Type that in, we get x equals 1.34 meters. But the thing is, I don't need to ask my calculator to give me that value of tan 24 degrees. I can simply leave it as tan of 24 and type it into the calculator, so I don't need to write out this ridiculous number of decimals, and I don't need to round here where I did. So instead of doing this when we solve, normally what we do is we simply go from tan of 24 degrees equals x over 3, getting kind of messy here, multiply both sides by 3, 3 tan 24 degrees equals x, type 3 times tan of 24 into the calculator, x equals 1.34 meters. So all this stuff over here, I don't need to do. I don't need to write out the value of tan 24 because I can just use that in my formula. But that's the reason that this trigonometric ratio works for finding an unknown side. Going back to our steps, Label the sides. Choose the ratio that uses the sides that we have, the unknown and the one that we do know. Substitute the values in and solve the equation.